What is going on, my brothers and my sisters? I am your host, your brother, your professor, Mr. O'Neill Barnaby, founder and director of the Black Math Academy, here with another video showing you what intelligent black society is all about. Welcome to part 2 of my 4-part series on how to solve quadratic equations. In this video, I'm going to talk about step 2 of my 4 steps, which is the AC method. So I'm going to give you guys an example to demonstrate how to go about solving quadratic equations using the AC method. I know it seems kind of hard, it seems difficult, I know. It actually reminds me of a reggae song from when I was young. It goes, do 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 ho what the what go a pumpkin belly do 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 who asked me that know me whole time granny do 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 do. Yeah, it means like a mystery or that can't be solved. For those that don't know, I am in part Jamaican, but with that said, let me show you how to do that. All right, so again, here are my 4 steps. Pull out the GCF, the AC method, complete the square, and the quadratic formula. I'm going to show you the second step, which is the AC method. All right, so if you recall, you need to have the quadratic equation written in standard form. Standard form, once again, looks like this, where you have ax squared plus bx plus c equaling 0. So whatever the quadratic equation is, it needs to be written in this form before you can even do any solving. All right, so to give you guys an example to go about solving quadratics using the AC method, let's say you had 2x squared, plus 3x minus 20 equaling 0. Okay, so we have 2x squared plus 3x minus 20 equaling 0. All right, so one thing you want to notice is that the value of the a term, or the coefficient of the x squared term, in our example is 2. In previous examples, or most of your quadratic problems, typically it's a 1, which allows you to just factor it like you normally would any other quadratic equation. You find factors of the last number that add to the middle number, and you do your thing. But we can't do that for this problem because the coefficient of the x squared term is not 1. It's some other number. In our case, it's a 2. So we can't just factor it the old-fashioned way. So here's where you would use the AC method to solve it. So it's in the name AC. So the AC method, here's AC, meaning A times C. So in our standard form of a quadratic equation, here's the variable or the coefficient A, and here's the coefficient C. So we're going to multiply those two numbers to start out. So our A is a 2, and our C is a negative 20. So we're going to multiply 2 and negative 20. 2 times negative 20 is negative 40. Now that we have negative 40, now we're going to find factors of that add to the middle term this time. No longer will you, like in previous problems where you find factors of the last number that add to the middle number. In the AC method case, you find factors of the product of these two, and those factors must add to the middle number this time. So in our example, for negative 40, we want factors of negative 40 that add to a positive 3. All right, so it may take it may take some time to be able to figure that out. You definitely want to make sure you know your rules of divisibility to help you out with that. You should check out my video on the rules of divisibility when you get a chance. So factors of negative 40 that add to 3 would be a positive 8 and a negative 5. So 8 and negative 5. 8 times negative 5 is the negative 40. 8 plus negative 5 is a positive 3. So those two numbers are the right values. So what we're going to do in this case is we're going to use those two numbers, the 8 and the negative 5, and we're going to rewrite the middle term. Let me show you what I mean. So I'm going to rewrite this entire equation using these two numbers to replace the middle term. So 2x squared, that was the first term. This 3x we're going to change by using these two values instead. So since 8 is positive, plus 8x. Since 5 is negative, minus 5x. And then minus 20 comes down, still equaling 0. Let me just kind of box this out. And here's your equation. 2x squared plus 8x minus 5x minus 20 equaling 0. And you see the 8 and the negative 5 are being replaced here for the 3x. Because 8 minus 5 is 3. So all I did was just change the way it looks. All right? Now, at this step, what you want to do is separate the equation in half. So right down the middle, so 2x squared plus 8x, and then the negative 5x minus 20, you're going to split it down the middle. Right there. And what you're going to do is factor this equation by grouping. So this part of the equation here and this part of the equation here, those are the two groups. And we're going to factor those two groups individually. Let me show you how. 2x squared plus 8x, what we're looking for is the GCF, or common factor. So I'll show you step by step between the numbers and the variables to show you what it looks like. So for this example, for 2 and 8, the GCF of 2 and 8 is 2. So 2 is what comes out of that expression. Now for the x squared and the x, they have a GCF as well. They have something in common. They both have at least one x in common. So x would be the GCF for those two terms. So x would come out as well. Now, as a result of factoring, you always start with the original and divide by what you pulled out, or your GCF. So 2x squared divided by 2x is going to give you what's inside the middle. And the 8x divided by 2x will also give you what's inside the middle. So 2x squared divided by 2x is just x. 8x divided by 2x is 4. And because it's positive, the plus sign stays inside the middle. And there you have it. So 2x is outside, and then x plus 4 is inside the parentheses. So we're going to perform that same factoring operation on the other side, the negative 5x and the negative 20. But to make sure that we know that we're doing it correctly, whatever we pull out, whatever that GCF is for the second part, what's inside the parentheses needs to be the same thing as what we just did, this x plus 4. So whatever we pull out from the second part of that expression, this part here, the result inside the parentheses needs to say x plus 4 as well. If it doesn't, it's not right, or you're doing it wrong. So the GCF for the numbers, negative 5 and negative 20, would be 5. But in this case, we want to pull out a negative 5 because the negative, when you pull the negative value out, this becomes positive and so does that, which is exactly what our first parenthesis says. They're both positive terms. So we're not going to pull out a 5. We're going to pull out a negative 5. So negative 5 comes out. There are no other common factors because they both don't have a variable, so we can't pull that out. Now the result, what's inside the parentheses, is when you take the original and divide by your GCF, or what you pulled out. So negative 5x divided by negative 5 is just x. Negative 20 divided by negative 5 is a positive 4, still equaling 0. And there you have it. So we have a negative 5 that was pulled out. X plus 4 remains inside the parentheses, and it looks just like the other parentheses we pulled out in the beginning. That means we're doing it correctly. Now, where to go from here is, let me show you with another marker. The 2x and the minus 5, the two GCFs that we pulled out of their respective parts of the equation, they're going to become their own binomial. So this 2x and this negative 5, we're going to put that in its own parentheses. So 2x minus 5 is one particular parentheses. The other parentheses, or the other binomial, will be the other one, the x plus 4. Even though it's both sides of the expression, we only want one of them. So we're going to create another binomial that says exactly that, x plus 4. X plus 4. Still equaling 0. All right, so now we have two binomials, 1, 2. When you multiply them, they equal 0. That means we have to apply the zero product rule, or the zero product property, which means set them equal to 0 and just solve them algebraically. So we've got the first one, 2x minus 5 equals 0. And the other one says x plus 4 equaling 0. So for the first one, you would add 5 to both sides first. You get 2x equals 5. Excuse me. Then you would divide both sides by 2. You get x equals 5 over 2. Let me write that again so you can see it clearly. 5 over 2. So the fraction 5 over 2, or 5 halves. For the other one, solve that algebraically. First, you would subtract 4 from both sides. You get x equals 4. Oh, sorry, x equals negative 4. My bad. So one solution is x is equal to 5 over 2, and the other solution is x is equal to negative 4. And there you have it. When you plug 5 over 2 in the original equation, the 2x squared plus 3x minus 20, you should get 0. And when you plug negative 4 into the original expression, you should also get 0. And that's how you know you're doing it correctly. All right, there you have it, folks. Once again, the Black Math Academy demonstrates why we are your premier source for mathematics tutoring. We are clear, we are concise, and we are articulate, which makes us without peer. Don't forget, like, share, comment, subscribe, and follow all of our social media pages, our Facebook, Instagram, and YouTube. And always remember, avoid the avoidable. Math is where it's at, y'all.